smoke columns are rising from the Hope Ranch bluffs right now. This is the 5th documented eruption event since 2017. Sulfurous gas plumes are visible from the UCSB campus, 6 miles away. Fire engines and a battalion chief are already on scene. This is the most visually dramatic eruption in years.
Ranch is home to a volcano, and today it sparked a small brush fire. Santa Barbara County Fire.
There is no volcano beneath Santa Barbara County. The nearest active volcanic system sits hundreds of miles north in the Cascade Range. Yet the Hope Ranch bluffs are producing sulfur, smoke, and heat on a scale visible across the entire UCSB campus. Scientists are stunned. Locals are equally baffled. The bluffs are not supposed to behave like this. They are sedimentary cliffs, not geothermal vents. But the smoke does not care what the geology textbooks say. The plumes keep rising, the smell keeps spreading, and the intensity keeps building. This event is different from the 4 that came before. The columns are taller, the odor is stronger, the visual reach is unprecedented. Something beneath those bluffs is reacting faster and hotter than it has in recorded history. And no one can explain why it is accelerating now. Spontaneous combustion is what happens when iron sulfides meet hydrocarbons meet oxygen. The Hope Ranch bluffs contain all 3. Erosion strips away protective layers. Landslides expose reactive strata to air. The chemistry is simple and violent. Iron sulfide oxidizes. The reaction is exothermic. Heat builds. Temperature climbs past the ignition point of surrounding hydrocarbons. Fire erupts. Sulfurous gas vents. The plumes mimic true geothermal solfataras found at active volcanic sites. But this is surface chemistry only. No magma. No seismic threat. Just geology eating itself in slow motion. The bluffs are not a volcano. They are a chemical reactor with no off switch. And every storm, every wave, every landslide exposes fresh fuel. The cycle repeats. The fires reignite. And the question no one is asking is how much reactive material remains buried in those cliffs. 2017. Hope Ranch. First, smoke. That was the year locals stopped calling it erosion and started calling it something else. The Hope Ranch Volcano. The name stuck because the phenomenon kept coming back. Same bluffs, same sulfur smell, same rising plumes that looked exactly like ignition, but moved slower than any flame should. The Santa Barbara Independent covered a repeat event in 2019. By then, the pattern was clear. Winter storms erode the cliff face. Spring exposes fresh layers. Summer heat triggers oxidation. Smoke rises. The cycle repeats. 2020 brought another activation. 2021, another. Each time, the erosion carved deeper into the bluff, peeling back sediment like layers of an onion. And each layer contained the same iron sulfide deposits waiting for air. The bluffs were not erupting, they were breathing. Every landslide was an inhale, every plume of smoke was an exhale, and the fuel source was not depleting. It was expanding, because the more the cliffs eroded, the more reactive surface area was exposed to oxygen. The locals had given it a name, but no one had given it a classification. No hazard designation, no warning system, just a recurring phenomenon that fire departments monitored until it stopped smoking, and then waited for it to start again. Which brings us to the question no one was asking. In 2017, or 2019, or 2021, if this keeps happening, what does the official record say? But here is the detail no one is talking about. The United States Geological Survey has documented hydrocarbon seeps along the California coast for decades. Extensively. The Santa Barbara Channel is one of the most active natural seep zones in the world. Oil, gas, methane, all of it bubbling up from deep geologic formations, leaking through fractures in the seafloor and coastal bluffs. The USGS knows this coastline. They have mapped it, sampled it, published reports on seep density, chemical composition, and emission rates. The data exists, but the Hope Ranch Bluffs are not classified as a seep site. They are not on the hydrocarbon seep inventory. They are not flagged as a geologic hazard zone. They are simply eroding coastal cliffs with occasional smoke events that fire departments treat as isolated incidents. And here is where the chemistry becomes the story. Iron pyrite oxidation is not a slow burn. It is an accelerating reaction. The more surface area exposed, the faster the oxidation rate. Each erosion cycle does not just expose fresh pyrite. It increases the total reactive surface, which means each cycle burns hotter and faster than the last. 2017 was smoke, 2019 was smoke, 2021 was smoke. April 2025 was flames visible from the beach. The progression is not random, it is exponential. And yet no federal reclassification has been issued, no public hazard upgrade, no geologic survey to map the full extent of pyrite deposits beneath the bluffs. The USGS has the tools. They have the protocols. They have done this work elsewhere, but not here. Which raises the question: if the agency that documents hydrocarbon seeps has not classified this site, and the agency that monitors geologic hazards has not issued a warning, who decides when a recurring chemical fire becomes a public safety issue? The answer, apparently, is the fire department, and they have been watching this site for 8 years. Michael Gray is a battalion chief with the Santa Barbara County Fire Department. He has been responding to Hope Ranch Bluff smoke events since the pattern began. And in a recent interview, he said something that should have made headlines. Quote, "I've always just accepted it as the Hope Ranch volcano. Accepted. Not investigated. Not mitigated. Accepted. The fire department's role is clear. Monitor the site. Deploy personnel if vegetation ignition risk increases. Wait until the combustion cycle stops. Then leave. No evacuation orders. No hazard perimeter. No long-term containment plan. Because technically, this is not a fire. It is a geologic process. And geologic processes do not fall under fire suppression protocols unless they threaten structures or spread to vegetation. But the heat is real. Underground drainage pipes running through the bluff have been damaged by prolonged thermal exposure. The chemical reactions are producing sulfur dioxide, which is a respiratory irritant. And the oxidation is not stopping. It is cycling. So the fire department monitors and waits and responds when the smoke gets thick enough to worry about. But they do not call it a hazard. They call it the Hope Ranch volcano, and they accept it. Which brings us to the footage you are about to see, because acceptance is not the same as understanding, and monitoring is not the same as control. Here is what is not making headlines. The numbers stack. 5 documented activation events in 8 years. 2017, 2019, 2020, 2021. And now that is one ignition every 16 months on average. But the intervals are not regular. They are compressing. Hydrogen sulfide becomes toxic at 100 parts per million exposure. The gas seeps from the same cracks that feed the flames. No public air quality monitor sits on the bluffs. No federal sensor network tracks concentrations downwind. UCSB campus sits 3 miles east, 26,000 students within visual range of the plumes. When the wind shifts onshore, the sulfur smell drifts across Isla Vista. Students post about it on Reddit. The university has issued 0 formal health advisories. The Santa Barbara Channel holds more than 20 mapped natural hydrocarbon seeps. Most sit offshore. The Hope Ranch Bluffs are one of the few terrestrial vents still active. The USGS knows this. The county knows this. The fire department knows this. Wildfire risk zone. Coastal chaparral ignites at relative humidity below 50% April through October. The bluffs sit in red flag conditions more days than not. One ember from a hydrocarbon flare could spark a brush fire that runs upslope into Hope Ranch proper. 1,200 homes. 0 fire breaks between the coast and the ridgeline. Fire response on April 23rd. 1 engine, 1 battalion chief. 0 structural threat declared. The incident log lists it as a vegetation fire, not a seep ignition. The response time was 14 minutes. The fire was already out when they arrived. No evacuation protocol exists for a seep-driven wildfire. No pre-position suppression resources. No public warning system tied to seep activity. The numbers when you stack them are staggering. 5 events, 20 seeps, 26,000 students, 1,200 homes, 1 engine. But the numbers alone do not capture what it looks like on the ground. They do not show you the color of the smoke or the sound of the gas venting through fractured sandstone. They do not tell you what it feels like to stand on a coastal path and watch the earth burn without ignition. For that, you need to see it. Picture it. April 23rd, Hope Ranch Bluffs, Santa Barbara. A UCSB student jogging the coastal trail smells sulfur before seeing any smoke. Sharp, rotten egg. Strong enough to make her stop and look around. Then she sees the plume. Yellow-gray smoke rising against Pacific blue sky. Not from vegetation, from the cliff face itself. The smoke does not billow. It streams, steady, vertical, like a chimney with no structure beneath it. She pulls out her phone and starts recording. A fire engine idles on the access road above the burning section. Lights off, no hose deployed. The crew stands near the guardrail watching. One firefighter points toward the source. Another takes photos with a department-issue tablet. Locals walk dogs on the path below. Some stop and stare. Some keep moving. One man with a golden retriever does not even glance up. He has seen this before. The smoke thins as the wind shifts offshore. For a moment, the plume disappears entirely. Then it thickens again. The cycle repeats. On, off, on. No flames visible from the trail. Just heat shimmer above the rocks and that yellow-gray column twisting upward. The student uploads the video to TikTok with the caption, "Hope Ranch Volcano doing its thing again." It gets 14,000 views in 6 hours. But the footage raises more questions than it answers, and those questions lead to people who have been asking them longer than anyone else. Here are the questions. If 5 events in 8 years means an accelerating erosion cycle, when does it stop? Does the sandstone collapse inward? Does the seep vent widen? Does the gas pressure increase until ignition becomes continuous? If 26,000 UCSB students are in hydrogen sulfide range during an onshore wind event, who measures air quality in real time? Who sets the threshold for campus evacuation? Who alerts the dorms? If coastal chaparral ignites during red flag conditions and fire runs upslope into Hope Ranch, which evacuation route stays open when Sandpiper Road is the only artery out? No federal agency has issued a public hazard classification for the Hope Ranch seeps. No state geologist has published a risk assessment. No county emergency plan includes seep-driven wildfire scenarios. The fire department monitors. The USGS documents. The locals record video. But no one answers the questions. And right now, the bluffs are still burning. Right now, the Hope Ranch bluffs are still venting sulfurous gas. The iron sulfide is still oxidizing.